This video is for class 9 physics, and in this video we are solving the numerical problems from exercise 8a. So here are our four working formulas, which are: number one, frequency of a wave is equal to the reciprocal of the time period, that is 1 upon t. Number two, let me change the color. Vt, that is the velocity of the wave, multiplied by its time period, shall give me the wavelength of the wave, and the velocity of the wave or the speed of the wave is equal to the product of the frequency and wavelength. The last one, which is very common, that is the velocity of the wave is equal to the distance moved by the wave upon the time taken by the wave. So these are the four working formulas which we need to solve the numerical problems from exercise 8a. So coming to the first question, the heart of a man beats 75 times in a minute. So here 75 times in a minute. What is its frequency and the time period? Okay, so here they are giving us the number of times, okay, number of times which can be denoted by n in 1 minute, that is 60 seconds, right? So in 60 seconds the number of times is 75. So what will be in 1 second? Whatever number you are getting, that should be the frequency from its definition, because frequency is the number of times in 1 second, number of times of vibration, number of time of oscillation, right? Number of times of anything which is done in 1 second will be its frequency. So we are supposed to find the number of times in 1 second, so that will solve my problem, okay? And then we have time period. We can use the formula f equals to 1 upon t and then calculate the time period. So I hope you have understood the question. So let us go to its solution. So in number one, the frequency should be the number of times in 1 second, right? In 60 seconds the heart beats 75 times, but in 1 second the heart should beat 75 upon 60 times, right? 75 upon 60 times using unitary method. Therefore the frequency of the heart should be same thing, that is 75 upon 60 hertz, right? And thus after dividing we shall get 1.25 hertz. Then the time period, that is the second part, okay, this is the second part. The time period should be 1 upon frequency, that is 1 upon f, and that is 1 upon 1.25 hertz. So after calculating we are getting time period capital T equals to 0.8 seconds. So I hope you have understood number 1. Let us go to question number 2. So we have come back to the book. The time period, that is number 2, okay, we are doing number 2, right? And the time period of a simple pendulum, I hope you know what simple pendulum is, 2 seconds. So here they are giving us the time period. Find its frequency. So what will be its frequency? So simply we can use this formula f equals to 1 upon t and then find the value of f for this number, right? So let us solve this. So the solution of number 2 will be given, right? T equals to 2 seconds, okay, and using the formula for frequency equals to 1 upon time period. So f will be equal to 1 upon 2, which shall give me 0.5 hertz. So I hope you have understood number 2. This is quite easy, right? Now coming to the question number 3, the separation between two consecutive crests in a transverse wave is 100 meter. So the separation between two consecutive crests in a transverse wave is 100 meter. Suppose we consider this as a wave here, okay, and suppose this is the crest here and this is the trough here, right? And they are saying the distance between the two consecutive crests. So what is this distance known as? Actually it is lambda, which is the wavelength. So indirectly they are giving us wavelength. So wavelength here is 100 meter. If the wave velocity, which is v, equals to 20 meter per second, find the frequency of the wave. Now we can use the formula, okay, which says v equals to f lambda, and thus calculate the value of f. So lambda is given and v is also given. So let us solve this question number 3. Separation between two consecutive crests means wavelength, right? Wavelength of the wave. Therefore I can write wavelength, that is lambda, equals to 100 meter. Velocity of the wave or the speed of the wave is given as 20 meter per second, but the frequency is question mark. Now using the formula v equals to f lambda, and then putting the values of v and lambda, that is v is 20 meter per second equals to f multiplied by 100 meter. Thus after cross multiplying, okay, or moving this 100 on the other side, we shall get 20 meter per second upon 100 meter, and thus we can cancel it. After cancelling, we are getting f equals to 1 upon 5 per second, right? This per second here, per second, or we can write 0.2 hertz. 1 upon 5 means 0.2, right? Per second means hertz. So I hope you have understood this question as well. Now let us go to the next question. Now coming to question number 4. A longitudinal wave travels at the speed of 0.3 meter per second, right? So the v is given, and the frequency of the wave is 20 hertz. F is also given. Find the separation between two consecutive compressions. As you all know, the separation between two consecutive compressions should be the wavelength. So using the formula v equals to f lambda, which you have used in the previous sum also, we can calculate the value of lambda. Here lambda is question mark, right? So let us solve this. So in question number 4, given v equals to 0.3 meter per second, f equals to 20 hertz, or we can say 20 per second, and lambda is question mark. So using the formula v equals to f lambda, we can write 0.3 meter per second equals to 20 hertz multiplied by lambda, okay, and thus by moving the 20 hertz on the other side, we shall get this here, 0.3 meter per second upon 20 hertz. Now thus by doing the simple calculation, 0.3 by removing the decimal point, I shall get a 10 in the denominator, and as you can see, hertz can also be written as per second. So this per second and per second cancels out, okay, and then further solving it, we are getting 3 by 200 meter equals to lambda, right, which shall give me 0.015 meter, right, equals to lambda. Now therefore lambda equals to 1.5 centimeter. So to convert this meter into centimeter, as you all know, 1 meter should have 100 centimeter. So 0.015 multiplied by 100, okay, shall give me 1.5, okay, shall give me 1.5. Thus I am getting 1.5 centimeter. So I hope number 4 is clear. Sorry, yes, number 4 is clear as well. Now coming to the next question, which is question number 5. A source of wave produces 40 crests and 40 troughs, right? 40 crests and 40 troughs. That means the number of waves is 40 only, because one wave should consist of at least one crest and one trough. Okay, one wave should consist of one crest and one trough. Here we are having 40 crest and 40 troughs, so therefore the number of waves should be 40 in 0.4 seconds, right? So 40 waves are created. Waves are created, okay, are created in how many, in how much time? In 0.4 seconds. Then from this data we are supposed to find the frequency. So the frequency is question mark. Okay, let us try to solve number 5 also. So coming to the solution of number 5, according to the question, number of wave produced are 40, okay, in 0.4 seconds, right? So I can write in 0.4 seconds number of waves equals to 40. So in 1 second, this is 1, okay, in 1 second this is 1, right, ONE1. So in 1 second the number of waves should be 40 upon 0.4, so which on calculating shall give me 100. Thus the frequency should be 100 hertz. Thus the frequency should be 100 hertz. So coming to the next question, number 6. An observer A fires a gun and the another observer B at distance of 1650 away from A hears its sound. If the speed of a sound is 330 meter per second, V is given 330 meter per second, find the time when the B will hear the sound after firing by A. So we are supposed to find the time. So time here is question mark. So simply we can use V equals to d upon t as the formula. V is also given, d is also given, but we are supposed to find the time. So let us go to its solution. So coming to the solution of number 6, given distance is 1650 meter and the velocity of the sound is 330 meter per second, and supposed to find the time. So using the formula V equals to d upon t, we can write t equals to d upon v, right? We can write t equals to d upon v here, and thus replacing the values of d and v. D is 1650 meter of over 330 meter per second. Meter and meter gets cancelled, and then by simple cancellation, right, with 11 and then by 3 I'll get t equals to 5 seconds. Okay, yes, I'll get t equals to 5 seconds. So I hope this is clear till here, right? Number 6. Let us go to number 7. Now coming to question number 7, the time interval between a lightning flash, okay, the time interval between a lightning flash and the first and the first sound of the thunder is 5 seconds. Okay, so time given to us is 5 seconds. If the speed of sound in air is 330 meter per second, that is V is 330 meter per second, find the distance of the flash from the sound, that is D is question mark. So simply using V equals to d upon t, we can find the value of d. Please try it by yourself. Okay, please try number 7 by yourself. It's somewhat like number 6. Okay, only the thing which you need to calculate is different, right? So let us go to the next number, which is number 8. Question number 8 reads as, a boy fires a gun and another boy at a distance hears the sound of the fire after 2.5 seconds. So time given to us is 2.5 seconds. So after seeing the flash, if the speed of the sound in air is 340 meter per second, right? So this is the speed of sound. Find the distance between the boys, again using the formula V equals to d upon t. Then I can write d equals to V multiplied by t. Thus multiplying this number and this number, we should get the answer, right? So please try it by yourself. Then please try number 8 also by yourself. So going to the next number, which is number 9. An observer sitting in a line of 2 tanks watches the flashes of the 2 tanks firing at each other at the same time, but he hears the sound of the 2 shots 2 seconds and 3.5 seconds after seeing the flashes. If the distance between the 2 tanks is 510 meter, find the speed of the sound. So here is the diagram to explain the question. So an observer sitting in line of the 2 tanks. So here is the here are the 2 tanks and the observer sitting in a line. This observer is watching the tanks firing to each other, right? This observer is watching the tanks firing to each other. Now what happens is, he hears the first sound after 2 seconds and the second sound after 3.5 seconds after seeing the flashes. Obviously here the flashes will be at the same time. Okay, the flashes will be at the same time here also and here also, right? Since the observer is closer to this tank here, right? Let us consider tank A, right? So what happens, he hears this sound faster, okay, in 2 seconds, right? And he hears the sound from this tank when the sound travels to him, and this sound, it takes 3.2 seconds, right? I hope you are sorry, 3.5 seconds, 3.5 seconds, right? So here the two sounds, sound 1 and sound 2. Now the other thing which is given to us is the distance between the tanks, which is 510 meter, 510 meter, right? So these are the things given to us. Now as you can see, the sound is taking 2 seconds from this point. Let me take another color here, okay, probably this blue will do. The sound is taking from here, this point, to this point 2 seconds, right? So from this point to this point also should be 2 seconds, right? So the remaining here from this point to this point here should be 3.5 minus 2, which shall give me 1.5 seconds, right? 1.5 seconds. So the sound travels, okay, between these two tanks in in 1.5 seconds, right? So the things which we have with us are, okay, let me change the color again to white, right? So things with us now are distance between the tank is 510 meter, right? And then we have the time, right, taken by the sound as 1.5 seconds, okay. So now my motive is to calculate the speed of the sound. My motive is to calculate the speed of the sound using the formula v equals to d upon t. Let us see what happens. V equals to d. D is 510 meter, right, upon time is 1.5 seconds. So let us try to solve this. So now I can write v equals to 510 multiplied by 10, because this point can be removed, right? So it becomes 15 here, and the unit becomes meter per second. So let us try to cancel this to, okay, 5 2 times and 5 3 times, okay. And if we try to cancel this 3 1 time, so 3 1 time and 3 7 times and with a 0, so we're getting 170 multiplied by 2. So therefore v can be written as 2 0 times is 0, 2 7 times is 14, 1 carry about 340 meter per second is the answer. So I hope you have understood number 9. So now coming to the next question, which is number 10. How long will sound take to travel in A, an iron rail, right, and number B, in air? So there are two parts of the question. Both in both the cases the distance is 3.3 kilometer in length. Take the speed of sound in air as 330 meter per second, and that in iron is 5280 meter per second. So let us try to solve this one by one, okay. And here we are supposed to find the time. So we can use the formula v equals to distance upon time to do this sum. We have distance along with us, we have v along with us, then we need to calculate the time. So time is question mark, right? So let us solve this. So coming to the solution of number 10, okay, A, right? For A it is iron rail, right? So given things, so given the speed of the sound is 5000, right? It is 5280 meter per second, and the distance between this distance of that iron rail is 3.3 kilometer, 3.3 kilometer. This can be converted into meter by multiplying it by 1000. Thus I shall get 3300 meter as my answer. So using the formula for the velocity or the speed, that is distance upon time, then cross multiplying it, I shall get t equals to distance upon velocity or the speed. Thus I can write time equals to distance was 3000 300 meter upon 5280 meter per second, right? So I hope you are understanding this. Okay, so meter and meter gets cancelled, 0 and 0 gets cancelled. Please do the cancellation in rough. Okay, after cancelling we should get 0.625 as our answer. 625 as our answer seconds. So I hope you have understood number 10a. Let us go to the next part, which is number 10b. So number 10b, this is for the a, right? So here the distance given is again 3.3 kilometer, right? So this needs to get converted into meter by multiplying it by 1000. So I shall get again 3300 meter, right? The other thing which is given is the velocity or the speed of sound in air, which is 330 meter per second. That is 330 meter per second. So here the time is question mark. So using the formula V equals to d upon t, or I can write t equals to d upon v. Okay, thus further solving it, I shall get t equals to d is 3300 meter, right? And the time and the velocity is 330 meter per second. So this cancels, 0 0 cancels, and thus I am getting 10. So therefore time equals to 10 seconds. Therefore time equals to 10 seconds. So I hope you have understood this particular sum. Let us go to the next question. Now the last numerical problem, that is number 11. So assuming the speed of sound in air equal to 340 meter per second, and that in water is 1360 meter per second. Find the time taken to travel a distance of 1700 meter by sound, both in air and water. Okay, so here speed is given, right, in the water. Speed is given in the air, right, in the water, in the air and in water, right? And then distance is also given, like in this case distance is given, speeds are given, same, right? So in this also you are supposed to find the time taken. In this case was also you are supposed to find the time taken. So this number 11 is same as number 10, so please try it by yourself. Okay, so I hope you can do all these sums by yourself also. So thank you so much, this much for this video.